Number 33. 33 tells us to find an equation of the line that is tangent to the graph of f and parallel to the given line. And so our f is x cubed, and our line is 3x minus y plus 1 equals 0. Now, starting out, I'm going to start this a little differently than I did in class, but solve for y, and that way you have the slope-intercept form of a line. And so our slope is 3, and so that gives us a place to work towards. Now remember, we're trying to find a line parallel to the slope. And so this is actually the slope of our parallel line as well, because the slope of parallel lines are the same. So this is the slope of the parallel line. And if we're looking for slopes in functions, we know that the derivative describes the slope of a function at a specific point. Okay. And so what we're really looking then is we're really looking at what is the derivative of f. And we have to find that. Recall that the derivative of a function, or f prime of x, is equal to the limit as the change of x tends to 0 of f of x plus delta x minus f of x all over delta x. Okay, so this is really the slope. This is y2, y1, and then this is the difference of x2, x1. Okay, we're just squeezing that difference very, very small. So we have to find that derivative. Let's get started. If we take and we substitute x plus delta x into x, then we get this. F prime of x is equal to the limit as delta x tends to 0 of x plus delta x quantity cubed minus x cubed all over delta x. And this you can expand using the binomial theorem or just knowing Pascal's triangle. This is the limit as delta x approaches 0 of x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed minus x cubed all over delta x. If you can't see it, don't forget that x plus delta x cubed is really x plus delta x times x plus delta x times x plus delta x. And so you can just go through and multiply it out that way. Okay, so now what we can do then is we notice that we have a negative x cubed and a positive x cubed. Those cancel. And now every term has at least one delta x, and therefore the delta x's cancel. That cancels with this, cancels with that cancels with that, and becomes a 2. And so after all the cancellations, I have the limit as delta x tends to 0 of 3x squared plus 3x delta x plus delta x squared. And now we can go ahead and we can take that limit. That way f prime of x is equal to, well, since that goes to 0, this goes to 0, this goes to 0. And so what we're left with is just the 3x squared. Okay. So now we have our slope. The slope of the tangent line is 3. This is from up above. Okay, this is the slope of the parallel line. And so we know that the slope of the tangent line has to be 3. We also know that the slope of the tangent line is 3x squared. And so if the slope equals the derivative which means 3 is equal to 3x squared, which if we divide by 3 on both sides, then we notice it's 1 is equal to x squared, and so x is equal to 1, or x is equal to negative 1. And that's over here, it's x squared is equal to 1, x is equal to plus or minus the square root of 1, and so this is x is equal to plus or minus 1. So what this is doing is it's telling us that the slope of the tangent line is 3 at 2 points, at when x is equal to 1 and negative 1. And so we kind of have to find those 2 points. Now, we have x, but we need y also. We can't just take x. And so I am going to include, if x is equal to 1 and negative 1, what is y? Okay, so x equals 1, y is equal to x cubed, which is 1 cubed, which is 1. So this is the point 1, 1. If x is negative 1, then y is equal to negative 1 cubed, which is negative 1. And so this is the point negative 1, negative 1. All right, now we have to be very careful here, because we want parallel to this. And so we have to make sure that we are including all of the possible solutions. Since there's 2 answers, let's include both. All right, and so we need the lines that pass through these 2 points and has a slope of 3. All right, so number 1. This is number 1, this is number 2. So from number 1, we know that y minus 1 is equal to, this is a point slope form, our slope is 3 times x minus x1. That's it. It never said that we had to put it in any specific format, and so that'll do. Now your book is going to give it to you in y equals mx plus b form, but I'm not going to require it. You can solve this out and know that this is what it is. Okay, the second one is y minus y1, so minus negative 1 is equal to 3 times x minus x1, or x minus negative 1. And that's it there. This is also y plus 1 is equal to 3 times x plus 1. And so there are your two possibilities for the tangent line that is parallel to our given line.